Hey guys, welcome back to my channel. Today we're going to do questions on transformation of graphs. This is part of the series for IGCSE Edexcel Maths 8 topic questions. We're using exam questions from 2018 onwards. If you check out the playlist in the link above, you will find several videos. Each video is on a different topic, and in each video you will come across exam questions which will greatly help you in preparing for your upcoming exams. So let's start with this one. It says the equation of a curve is y equals to f of x. There is only one minimum point on the curve, and the coordinates of this minimum point are 8, negative 12. Write down the coordinates of the minimum point on the curve with the equation y equals to f of x plus 3. So whenever we're adding or subtracting something directly from the function, like over here, it's f of x plus 3. If we're adding something, the graph moves that many units up. And if we're subtracting something, the graph moves that many units down. So if it is y equals to f of x plus a, the graph moves a units up. And if it is minus a, the graph moves a units down. So if it's moving up or down, that means it's only changing the y value. The x value remains the same. We have vertical transformation happening, not horizontal. So if it's y equals to f of x plus 3, that means for the negative 12, we will add 3 because we're moving the graph 3 units up. So when it goes 3 units up, it becomes negative 9. So x remains the same, y becomes negative 9. Then we have y equals to f of 2x. Now you're multiplying a scale factor directly to x. If you're multiplying something directly to x, what you do is you divide the x coordinate by that value. So over here, x is 8. So now x would be 8 divided by 2, which is 4. You will not multiply x by 8, you will divide x by 8. If it was like something being multiplied directly to f of x, then you multiply the y value by that number. But for x, the rule is opposite. If something gets multiplied to x directly, you divide the x coordinate by that number. So now the x value becomes 4 and y value remains as it is. So this is like how you transform your graph if there's vertical transformation. Like, if it's something, like for example, if you're adding or subtracting something from y, like the function, and then you have the transformation where your graph is either shrinking or becoming wider. Over here, your graph is shrinking because now the minimum point is at 4, not 8. So for x, the rule is opposite. For y, it's like, common sense. If something is being multiplied with f of x, you multiply the y value by that. If something is being divided by f of x, you divide the y value by that. If something is being added to y, you add that value. If something's being subtracted from y, you subtract that value. But for x, if you add something directly to x, that means you're subtracting it originally. And if you're subtracting something, that means you're adding. If you're someone who's still confused about these transformations, I'm posting a link above for a short that I've made on these transformations. That short gives a brief description of what, happens when you're transforming based on the different transformations. If something is being added to x or y or multiplied or divided. So you can check out the link above. And if you're still confused about what's happening, leave a comment below and I'll explain it again. Then it says a curve has equation y equals to f of x. There's only one turning point on the curve. The coordinates of this turning point are 6, 5. Write on the coordinates of the turning point on the curve with the equation. So now this is pretty much the same as the previous question, but part A is different. Now, they're subtracting something directly from x. So if you're subtracting something directly from x, you will move the graph that means towards the right-hand side. So y equals to f of x minus a means shift the graph a units to the right, not left, the right. And if it is y equals to f of x plus a, shift the graph a units to the left now. It's opposite. So if it is f of x minus 4, that means from x of the turning point, we're going to add 4. So 6 plus 4, that's 10. We're shifting the graph 4 units to the right side. So 6 becomes a 10 and y remains as it is. Then y equals to f of 3x. So this is the same as the previous one. Something is being directly multiplied to x. That means we will divide the x value by that number. So 6 gets divided by 3, which is 2. Again, the x value changes to 2, y remains exactly the same. When you're doing these transformations, if something is being directly happening to x, then only x changes, y remains the same. Same case for y. If you're just changing y, x remains exactly as it is. Now over here it says the diagram shows a sketch of the curve with the equation y equals to f of x. There's only one maximum point on the curve and the coordinates of this maximum point are 5, 7. Write down the coordinates of the maximum point on the curve with the equation y equals to f of x plus 9. Now we're adding something to 9, which means we will subtract 9 from 5 because we're moving the graph to the left-hand side now. So that's negative 4. So x value becomes negative 4, y remains as it is. Then y equals to f of x plus 3. We're adding something directly to the function, which means the graph will shift 3 units up. So that's 7 plus 3, 10. So x remains as it is, y becomes 10. In this one it says the curve C has equation y equals to f of x, where f of x equals to 9 minus 3 times x plus 2 whole square. The point A is the maximum point on C, right on the coordinates of A. So the equation given the question is in completing square form. And in completing square form, we can easily use this to identify what the maximum or the minimum point is, basically the turning point. So whatever is being added or subtracted to x, that is your x value, and then this is your y value of the turning point. So if something is being added to x, you write it as a negative coordinate. So that's going to be negative 2 and y is going to be 9. That is your turning point of this curve, which is your maximum point. If it was x minus 2 whole square, then you would just write 2 as positive 2. You wouldn't make it negative. But if it's x plus 2 square, it would be minus 2. Because if you remember, I told you when you're transforming the curve and something is being added or subtracted to x, if it's plus, you're moving it towards the left-hand side. If something is being subtracted, you move it to the right-hand side. So because of that, the sign becomes negative 2. Then curve C is transformed to the curve S by translation of 4, 0. So based on this vector, x is 4, y is 0. If x is 4, that means you're moving the graph 4 units to the right. If x was negative 4, it would be 4 units to the left. Same if y was like a non-zero value. If it was, let's say, 1, then you move the graph 1 unit up. If it was negative 1, you move the graph 1 unit down. So to find the equation of S, if C is being transformed by this translation vector, we're moving it 4 units to the right-hand side, which means it's going to be y equals to 9 minus 3 times x plus 2 minus 4. Why minus 4? Because when we're moving to the right side, we're subtracting that number. So that's 9 minus 3 times x minus 2 whole square. Nothing happened to the y value. What changed is the x value. Then says the curve C is transformed to the curve T. The curve T has equation y equals to 3 times x plus 2 squared minus 9. If we compare the two equations, 3 is positive now. Originally it was negative. 9 is negative now. Originally it was positive. So if we take negative sign common over here, that's 3 times x plus 2 whole square minus 9. So which means your y value is becoming negative, and y value can only be negative if it's reflected in the x-axis. So what's happening is that the graph is reflecting in the x-axis. If your x value is becoming negative, that means the graph is reflecting in the y-axis. So reflection is also a very important part when it comes to transformation of graphs. Then in this one, it says a curve has equation y equals to f of x. Coordinates of the minimum point on the curve are negative 9 and 15. Write on the coordinates of the minimum point on the curve with equation y equals to f of x plus 3. So over here, once again, we're directly adding something to x, which means we will subtract that from the x coordinate. That's going to be negative 12. Y remains exactly the same. And then it's y equals to 1 over 3 times f of x. So now the scale factor is being multiplied to the function. So that changes the y value. So it's 15 times 1 over 3, which is 5. So x remains as negative 9 and y becomes 5. Then since the diagram shows a sketch of part of the curve with equation y equals to f of x. There is one maximum point on this curve. The coordinates of this maximum point are 4, 6. Write down the coordinates of the maximum point on the curve with equation y equals to f of x plus 4. Something is being directly added to x, so we subtract that from the x value. So 4 minus 4, that's 0. So x becomes 0, y remains 6. Then y equals to f of 2x. So that means we divide the x coordinate by 2. 4 over 2, that's 2. So 2 and 6 is again the same. Then the curve of equation c equals to y equals to x squared plus 3x plus 4. The curve c is transformed to curve s under the translation 4, 6. Find an equation of curve s. You don't need to simplify the equation. Since the x value is positive 4, that means we're moving 4 units to the right. And y value is positive 6, so 6 units up. So since it's moving 4 units to the right, we will subtract 4 from x. So wherever there's x, we'll write x minus 4 now. And to y, we will just add 6. So just add 6 at the end of the equation. That's it. So x minus 4 whole square plus 3x minus 12 plus 10. So x minus 4 whole square plus 3x minus 2. It says you don't need to simplify the equation, so you can leave it as it is. You don't really need to expand the bracket. You will get a mark. Then since the curve with equation y equals to g of x is transformed to the curve with equation y equals to negative g of x by the single transformation t. Describe fully the transformation t. This is a reflection in the x-axis. Why? Because y value is becoming negative. So y value can only be negative if we're reflecting the graph in the x-axis. And like I said before, x value can only be negative if we're reflecting it in the y-axis. Then it says the diagram shows the graph of y equals to f of x. On the grid, draw the graph of y equals to 2 times f of x minus 1. Now there are two transformations happening over here. Y is getting multiplied by 2 and x is moving 1 unit to the right now. So we pick the turning point over here. That's 4 and negative 3. So x is moving 1 unit to the right. So 4 plus 1, that's 5. This is your x. And for y, the function is being multiplied by 2. So negative 3 times 2, that's negative 6. So now the turning point comes over here at negative 6 and 5. So that's over here. And what you can do is you can pick other points in the graph as well. Like I would suggest whole numbers. So if you pick this one, we use a different color. This and this. This one is 1 and 3. So 1, 3 becomes x equals to 1 would be 1 plus 1, that's 2. And y would be 3 times 2, that's 6. So 2, 6, that's over here. And this would be, again, 7 plus 1, that's 8. and y value would be the same. So if we connect this, this is your graph. So as you can see, the x value moved 1 unit to the right and the y value got multiplied by 2. So this is your graph for y equals to 2 times f of x minus 1. I'll also highlight the new coordinates over here. This is 5, -6. This is 8 and 6. This is 2 and 6. This is 1 and 3. This is 7 and 3. So this way you'll have a better idea as to how the transformation is happening. And this question says, here's the graph of y equals to f of x. On the grid above, draw the graph of y equals to 2 times f of x. So for this, 2 times f of x means that y is getting multiplied by 2. So 3 times 2, that's going to be 6. -1 times 2, that's going to be -2. So this point comes over here. This point comes over here, and this point goes at 6. So then we just connect the points with a straight line, and that's your graph. As you can see, nothing is happening to the x value. What's changing is the y value because the function is directly getting multiplied by 2. So x value remains the same at -2 and 4 and at 1. Y becomes 6 and -2. Then here's the graph of y equals to f of x. On the grid above, draw the graph of y equals to f of -x. So y equals to f of -x means that we are reflecting the graph in the y-axis because it's the x coordinate that's becoming negative. So this comes over here. So 1, 3 becomes -1, 3. -2, -1 becomes +2, -1. And 4, -1 becomes -4, -1. So each x point is reflected in the y-axis, and this is your new graph. Then says the point A with coordinates -3, 2 lies on the straight line with the equation y equals to f of x. Find the coordinates of the image of the point A on the straight line with the equation y equals to f of x minus 3. So if we're subtracting something from y, we subtract 3 from 2. So y equals to 2 minus 3, that's -1. So -3, -1. Then if you're dividing x by something, that means you will times the x coordinate by that number. So that's going to be -6. So x becomes -6 and y remains 2. Here's a sketch of part of the curve with the equation y equals to g of x. The point B with coordinates BQ lies on the curve. Find the coordinates of the image of the point B on the curve with the equation y equals to -g of x minus c. Two transformations are happening. X value is moving c units to the right-hand side, and y is getting reflected in the x-axis. So xp becomes, since p value is the x coordinate, so p plus c, and then for y, it becomes negative because we're reflecting it in the x-axis. So -q and p plus c for x. Then since the curve with equation y equals to f of x has one turning point, the coordinates of this turning point are -6, -4. Write down the coordinates of the turning point on the curve with equation y equals to f of x plus 5. So again, we're going to add 5 to the y value. So -4 plus 5, that's +1. X remains the same, y becomes +1. Then y equals to f of 3x. So that means we divide the x value by 3. So that's -2, and y value remains the same. The graph of y equals to g of x is shown on the grid below. On the grid, sketch the graph of y equals to 2 times g of x for x is greater than equal to -1 and less than equal to 7. So 2 times g of x means we're multiplying the y coordinate. So 2 times g of x means that we're multiplying the y coordinates by 2. So this. This is 3, -2. This is 8, 4. And this is -4, 6. So for the new graph, it's going to be 3, -4 over here. So in the question, they said that x has to be between -1 and 7. So for -1, our value is 3. So we can do 3 times 2, that's 6. So that means -1, that's going to come over here. Let me remove this. And then over here at 7, the value is 3. So again, 3 times 2, that's 6. So 7, 6, that's going to come over here as well. So that is our graph. Because at x equals to -1, y was 3. So 3 times 2 became 6. Then at x equals to 7, y was again 3. So 3 times 2 became 6. So when you connect the points, this is what we get. Then it says the graph of y equals to h of x intersects the x-axis at 2 points. The chords of the 2 points are -1, 0 and 6, 0. Graph of y equals to h of x plus a passes to the point with coordinates 2, 0, where a is a constant. Find the two possible values of a. So we have h of x, which has the points -1, 0 and 6, 0. Then we have y equals to h of x plus a. Horizontal translation is happening. We're moving a units to the left-hand side, which means we're subtracting a from -1 and a from 6. It says the graph of y equals to h of x plus a passes the point with coordinates 2, 0, where a is a constant. So since they've given us the translated coordinate, we can put 2 equal to -1 minus a. That's 2 plus 1 equals to -a. That's -3 for a. That is one possible value. And then for the other one, 2 equals to 6 minus a. So that's 2 minus 6 equals to -a. So that's a equals to 4. That's the other value. So you just have to use the transformation to create your own coordinates and then put the x coordinate equal to 2 to find the value of a. Since we're adding something to x, that means we move that many units to the left-hand side, which means we'll be subtracting a from -1 and 6. And with that, we're done with the questions of transformation of graphs. I'll be uploading a separate video which will explain the transformation of trigonometric graphs. So do check that out later. And if you have any questions or confusions, please leave a comment below. I'll help you out. And if you understood everything, please like and subscribe and share this video with your friends.